If you've never seen Pytest or unit testing, you're fine. The idea for this talk is to get you over the hump where you don't know what it's about and you don't know how to run it to a point where you feel comfortable enough with it to move on with more advanced tutorials that are going on. So so don't waste anyone's time. If you're looking for a super advanced Pytest tutorial, this is not it. This is getting started and getting familiar with unit testing. So let's do the traditional about the speaker and all that other stuff. So about me, I work at SpaceX. I taught a boot camp here for 6 months. So these two awesome girls were in my class. Hopefully they learned a lot. If you think I'm a terrible speaker, you can go complain to them. They had to deal with this for 6 months. So they'll be commiserators with you. I contribute a lot to RVs. That's going to become relevant later with testing. And we're happy that y'all came to PyData. So I'm one of the committee members for PyData. So thank you all for coming to this conference. It's the first year that PyData has existed. It's fantastic that you found it and you took the time on a Sunday to come out. And I super encourage everyone to come back on Monday and Tuesday as well when we have our keynote speakers and the rest of the talks. We have a social event tomorrow. We have lightning talks. So if you didn't get a chance to submit something and you still want to come and talk, we have that's available as well. I want to give a shout out. Nathan Danielson is in the back. He's the primary chair, one of the three, and he's spent a lot of weeks and weekends getting this going as well. So go shake his hand. He's a great guy. Ways to get hold of me. You have my LinkedIn and all that. And then disclaimer, everything is my own opinion. I don't represent anyone else but myself in this talk, so we'll get that out of the way. The other thing I want to say is you guys will be doing the majority of this tutorial. I'm going to pause for like 30 or 40 minutes cumulative over the time of this talk where you guys are going to be coding. So otherwise we'll just be staring at each other awkwardly for 10 minutes if you don't clone this repo and install the dependencies. So super encourage everyone to get a copy of this repo, Pytest for data science. There's actual activities we're going to go through. And so to prevent it from being boring, let's do that. So I would clone this and I would install the dependencies. Some of you probably have them installed. They're pandas, Pytest, and requests, so pretty small ones. But do a pip -r. So let me jump into the next section, tutorial format. So why am I doing it this way? Why do I sort of believe in this method? So git clone, install requirements. How this will go, I'm going to just conceptually talk through Pytest a little bit, so it'll be a little abstract. I'll wave my hands, and then we're going to just dive right into concrete stuff. I'll show you an example, and then you guys are going to try it out. This is super similar to the bootcamp format, which I found super effective. I want everyone to find a partner in this, and I see people sitting alone, and I'm not going to have that, because this is a conference, and we want you guys to network and meet other people. As diversity coach here, I want people to meet other people of different backgrounds. But there's also a real reason to this as well. This is not just a like let's be buddies type of thing. It turns out when you pair up with somebody. I'll give you a sec. Yeah, go ahead and give me a sec. So the reason I'm making you awkwardly introduce yourself is, well, one, you're at a conference, so you signed up for this a little bit, but it actually makes you learn. If there's Loma Linda has effective ways of learning, and we're going to go through all of them. We're going to learn in multiple ways. I'm going to show you. I'm going to talk about it. I'm going to show you in code, and then you're going to do it yourself. We're going to build examples from each other, and the biggest one, why I want you guys to sit next to each other, is if you teach somebody else. So I'm going to be teaching you, but you're going to learn more if you then work with your partner, and you guys both teach each other. I think the knowledge and the retention will be there. So my goal is not to just give you a bunch of information. My goal is to have you guys actually be able to use Pytest by the end of it. So you're not dazed and confused. I feel like a lot of tutorials, sometimes you're dazed and confused at the end. I don't want that to happen. I want you to feel secure in your knowledge about what's going on. So let's do why testing, and we'll talk about that. So why do we bother with testing things at all? So I do data science-y type stuff. One of the data science things that I do is I go to dinner with my girlfriend or whatever, and then I want to split the bill up. It's a data science problem. I have an input. I'm also kind of cheap and don't want to keep paying for her, so I want to cut it in half. And I wrote a function to do that because we have computers. Why do it? Why do it myself? So the function is really simple, and I'm going to use VI a lot because Vim is just a text editor that happens to be in the console. So this is my function. I have a Python function, split bill. It takes the input cost. Take the cost, I divide it by 2, And then I'm just going to print the cost, so I know how much this bill is, and then that's about it. So should be pretty simple. I take this one, Python, bill split, $2.5. Any surprises? Seems amazing. Nope, crazy. Nothing crazy. We'll do the same thing over here, $2. It's the same function. Does anyone want to guess why what happened? Exactly the same, huh? Yes. Yeah. But I'm running Python, right? Yeah, so it's the same command, Python bill split. Yeah, weird, huh? Anything look different? Yes. Somebody got it. Python 2 versus Python 3. So when I flipped the screens. Python, this one's 2.7, and this one is 3. And I know this, like, we're like, it's like 2019, everyone should get on board. Python 3, what is someone crazy? But there's differences with code, right? You write code on your computer, and it works, and you're like, cool, I wrote this awesome function. Let me just give it to my coworker, or NumFOCUS is all about open source. Let me open source this thing. Suddenly, somebody else is running your code, and nothing works. I guess, does anyone agree that division is a thing we do in data science? Seems like common? Yeah. So you would want your division to be correct, and if I wrote my library in Python 3, and my bill split function works correctly, if I give it to somebody else, everything's going to be off. Like, if your neural nets are going to be off, there's division there, your classifiers are going to be off, your matplotlib bars are going to be off, like, everything is just wrong. So the point of testing is that you're supposed to write down what you expect. And let's go through our first test. So, oh, by the way, questions, who answered? You answered? Yeah, okay. You get your chance. You want Kit Kat, Reese's, Hershey's? Hershey's? They got almond and you got normal. Almond? Yeah. Who got 2.7 versus 3? You want something? All right, are you guys also going to find out that I'm a nerd and I don't play sports? So I hope I don't hit someone in the face. Yeah. So if I accidentally hit you with a candy bar, but you guys are welcome to ask questions. They're super encouraged. I will gladly throw sugar your way.
I have a quick question.
Yes.
Where is your Python 3 and Python 2 lists?
Where do they live?
Yeah, because I have both on my computer, but one's in bin local, but one's in like the library.
Oh, okay, good point. So me in particular, I use Anaconda to split my environments up. So I use my Conda package manager, and I have in this computer I have 6 versions of Python from Anaconda. Then there's 2 from the Mac, by the way. And if you go to user bin Python, this is a little bit off the top, but we'll go with it. This is the version of Python that's built into your Mac, and there's actually 2. There's Python 3 and there's Python. That's Python 2 that's in Mac OS. I guess I don't have a Python 3 in this one. So I have at least 7 on this computer. This is a little bit aside. We'll go with it. With Python, it's important to split your environments up. So there's virtual env is one way of doing this. Another way of doing this is Conda. That's my favorite. So I use the Conda versioning, and then you have Docker containers are really popular. So there's actually Docker talk happening right now. Docker provides a layer of isolation, and then the most heavyweight one is VMs. But that's how I split up my Python environments. At work, I have like 26 of these because I have 26 different projects that I work on. I hope that helps. So this one was activated. This one should have been this is 3.5. Yeah, this one is the 2.7. You can see the difference here, 3.5 and then 2.7. And this one's the PyData environment, and this is just my normal root environment. It's cool. All right, you get something too. That's a good question. Kit Kat? All right. You want to do me a favor? You want to help me pass out candy so I don't kill people? You can also take one yourself. Go for it. Okay. Great question. Yeah. So it is but the point is, people have different versions of Python on their computers. Like there's a lot of different versions of Python. By the way, when you say Python, there's at least 2.7, and then within 2.7 there's minor and major revs. Then you have 3.1, 3.2, 3.4, 3.5, 3.6, and minor versions in between. You have to be sure that your code runs on the ones that you support, right? So that's why we write tests. So I'm going to show you that. Let's talk about why testing. How much time do I have? I should probably keep a lot of. Yeah. Okay. All right. So notes. I put some notes in here so you guys don't have to memorize what I'm saying. I might talk a little bit faster to get through. So Python 2 versus Python 3. Oh, let's talk about what is a bug. Oh, my computer wants to cooperate with me. All right. So what is a bug? It's an error, flaw, or failure in a computer program. My program had a bug in it. It said on Python 2.7, you get the wrong answer. So that's a bug in my program. It is not a bug in Python because Python was designed with that explicitly. So Python 2 does not have a bug. That's the way Python 2 works. If you divide 5 by 2, you don't get 2.5, you get 2. Language design choice, it's documented. The bug is in my program where I'm using it to do a thing, and it's not doing the thing that I want it to do. So testing helps catch bugs. So the motivation, testing helps catch bugs. We're going to see that in a second. I'll show you the example we just saw. But the other two benefits of testing is that they help users understand the program, and they help with code development and refactoring. So these two will become a little bit more apparent as I show you some examples. So let's jump into basic testing examples. All right, so let's go back to my single bash pane, cdo4. cdo4. Okay, so in my test, I have test bill split. And what I'm doing here is this is the first structure for a Pytest program. The structure is you bring in the code that you want to test. So in this case, I want to test my bill split module. You then write a function, and the function just has to say test somewhere in it. So in this case, I have test underscore in the front, and I'm testing bill splitting. It doesn't have to be the same. I could make this test bill splitting whatever. But the important part is that test is right here in the front. I have a doc string because doc strings are good. And then what I'm doing is I'm running my function, and then I'm writing an assert statement down here that says the split is equal to 2.5. That's what I want out of my program. Yes, sir.
There's no imports for Pytest?
Pytest does not require imports. So this is a really good. We'll go into the different testing libraries in a second. This is a Pytest style test. So Python has a number of different testing styles. Sometimes this is where Python fails at the one and obvious way of doing things, but there's other ones. We'll talk about that in a second. This is just Pytest. So let's run the test. So the way I run the test is I run Pytest test bill split.py. I run it, and I get my error. And I get 2 equals 2.5. This is good because we're on Python 2. So if I run this in Python 3, Pytest test bill split. Source activate. Whoops. Source activate root. This works. This is good because one test, when I run it in one environment, I get a nice error message that tells me I have a failure. This test failed. 2 is not equal to 2.5. My assert failed. In Python 3, you can see it right here actually. It even prints it for you. This is Python 2. This is Python 3. It runs. The dot means that it passed. I know it's a little unintuitive, and I'll make this a little more verbose. If you like to read and see that it really passed and it's in English language, you can put a -v flag, run -v, and it'll tell you explicitly that this passed. This is the test. This is the test module. This is the test function, and this passed. So where this is, let me pull up the README for this thing. I'll show you how this works in practice. So in practice, you run a Pytest by running it like this. In open source, this is actually how it runs. When I contribute to open source and either PyMC3 or RVs or whatever, if you look at this graphic, we're testing across 2.7, 1, 2, 3, 4, 5, 6, 7, 2.7, both in 32-bit and 64-bit versions, and 3.6. And we have both 64. 3.6 we're only testing in 64. So not only are we testing Python version, we're also testing the bit of the Python. So 32-bit and 64-bit versions of Python. This is to make sure that it works across every single supported version of Python.
What if your environment's super messy and you have a bunch of different Python
PyTest will run in the default. So this is a good argument to make sure don't have super messy environments. Isolate your environments so then there's only one version in each one. So this is where super messy environment, but this is a good reason. This is where super messy environments will hurt you. The code will work on your computer and it'll only work on your computer because there's some magical combination of dependencies that somehow conforms into being the thing that makes your code run, and it will never run on anyone else's computer. And you can't, it'll be hard to make it run on anyone else's computer. So it is what, this is a good maybe quick CI thing. And let me actually pull up an RV. I'll use RVs because it's the library that I contribute to. I'll show you how this sort of works. GitHub.com. Go to RVs. So I'll be doing a lightning talk on RVs later. It's a library for doing Bayesian Bayesian model criticism. So if you hit a Bayes theorem, there's libraries out there to make Bayesian models. It's a type of machine learning, and then you have to evaluate the models. And so this is a library that has a lot of plots and whatnot to help you evaluate the models. We want to make sure that this runs over a lot of people's computers. So what we do, and I'm going to go all the way into, actually, I should have clicked one back, all the way into my CI engine. In RVs, in Travis CI, every time we make a commit to master, or commit and make a push to the repo, Travis CI sees that and it runs tests across 3.5 and 3.6. RVs only supports 3.5 and 3.6, and we're actually running across 2 versions of Stan. In here, when you open this up and you look at the job log, it's going through and it's running 220 unit tests. And this is actually a small project. If you try to test pandas, it's got thousands of tests. So this is why we test. We want to make sure RVs works not on our computers, on all the people who want to use RVs as computers. That's the motivation behind testing. So this is the end of the theoretical section. Does anyone have any questions or feel like testing is still a waste of time? Don't need it? Any in this? Yeah.
If you're Docker, if I'm using Docker and I'm using a Docker image, would you say that testing isn't as important because it will run on your computer the same as it will run on my computer?
Sure. So you're running. That's a good point. If you're using a Docker image, your environment is the same, right? Because Docker isolates the environment for you. But does Docker guarantee that your code is correct?
No.
So that's why you still want to test. So this is when people say about test-driven development. Well, one point of testing is to know that it runs across all environments. In this case, we don't need it with Docker. But the other point is you write code, and your code could have a bug in it, and you don't know about it. Testing helps you catch those bugs. There's another class, by the way. This is a little bit more theoretical, but there's a whole notion in software development where some people think that if you write tests, you end up writing better code. So if you write tests first and then you write your code is better than if you write code first and then test later. That's the arguments back and forth about test-driven development, but that's probably the furthest reason I'd say to test. The first two are make sure it runs across all environments. The second is that you know your code works for sure. Actually, in the third, I think that is nice is that if you look at the code, we'll go back to flipping all over the place. Let's close this one out. If you look at the code, it actually makes it easy to tell what's supposed to happen. So my test split bill code, actually, when you read this, now somebody can sort of tell what it's supposed to do because it's one example of it in action. So testing helps new people understand your code base too. All right. So this is where I stop talking and I let you guys run your first test. So I'm going to admit all the solutions are in this solve folder. You can cheat and look at it first, but I'll admit you'll probably learn less. So my advice to you is try doing it yourself and banging your head against the wall for just a little bit. And then if you're really stuck, we'll go through this solution. So what I want you guys to do is I want you to, I'll open it in VI just to be consistent. I'd want you guys to navigate to this directory. Oh, whoops. Went back too far. PyTest. It is labeled activity. So everything labeled activity is things you're going to do. I want you to write a test to make sure this adder function works correctly. I want you. It's 05 in here. What I want you guys to do is write a Pytest file yourselves that verifies that this add function actually does addition correctly. So this add function. Does anyone want me to demonstrate the add function? Is it easy enough? Okay. If anyone has questions about how to use the adder function, let me know. But I want you to write I'm not going to show you the answer, but this is the test bill split function. I want you to write one that's like test add and make sure that adding works well. And I'll give you guys like 10 minutes to do it.
Can you make that bigger?
The font?
Yeah.
Ooh, this is going to be interesting. Okay. While you guys are doing the activity, I'll also change my terminal font size because it takes a little bit of effort. But otherwise, the code is all online. If you get it on GitHub, everything is there. So everything you see me doing is on the GitHub repo.
What's the GitHub repo address?
All right. GitHub repo is, let me pull it up. Is this readable? How about that? There we go. The front part is github.com, and then this is the actual like part that matters.
Are you using iTerm?
Am I using PyCharm?
The iTerm 2 for your terminal?
I don't know what I'm using.
Because command plus plus works.
Oh no, I'm using the regular terminal. I think I have to go in and change it. I'll do that. I know how to do
Command plus plus should actually work on this too.
it. Should I try it? Well, look at that. Perfect. All right. So 10 minutes. I'll give you till about 2 o'clock. So go ahead, discuss and try and figure it out. You got this, Tiffany? It's normal, right? You're just way back. You're like, shit, I got to do it myself. We record it. You're like, crap, I got to do it myself.
What's the answer?
All right, who has to? Questions are good. You guys want candy? Candy?
I'm stupid. I don't know how to do
No,
this.
you're not stupid.
Yes, I am.
This is good.
I'm trying to figure out how to run this.
All right, so, is this Windows? No, it's good.
No, it's
Okay,
Linux.
Linux is
Debian.
good. Love it. Okay,
I
so,
did Python.
oh, you want to run the test?
I'm trying to run adder just to see if this lags. I'm trying to figure out how to run it so I can write something.
Oh, okay.
So don't I have to do Python adder py?
No. Okay, so if you want to use adder, do you have
Well, I wanted to try it just to see what it's supposed to do.
Okay, that's fair. I should have put an example in here. Okay.
No, that's okay. Most people probably already know this.
No, but it's good.
Vim?
Yeah.
Should
No, you don't have to do. I just
I
know
use
that.
VI because everybody has it.
That's okay. VI works. So, I'll make one for you real quick. Yeah. Oh, I messed it up.
That's okay. I just didn't realize it. I thought it was already.
I should have. This is an oversight on my part.
No, it's okay.
The next ones will have it. I don't know how to use VI very well.
I just started forcing myself to use it, so I don't have. I got
Okay.
people like that.
VI has a really high learning curve, so don't worry about it if you don't. If name equals main.
I figured I should know what it does so I can test it.
No, that's a good point. You should know what it does to test it. Like that is the exact mentality you should have. Almost done. Print.
Now I have both 2 and 3 installed. Usually I use Anaconda. Is it Python 2, Python 3?
I would stick with Python 3
Oh yeah.
from now on.
I had to do them when I ran the test on your bills, but I had to do Python 2 and then the whole line you have, and then Python 3. It wasn't testing both of them. Now, I don't know if that's the way I have this set up.
No, what you have is actually. Oh, I should have used that. It was right there. Wow, I'm blind. Okay, so now this will actually run.
Okay.
So 2 plus 5 is 7.
Yeah. Okay. Thank you. Okay.
So what's happening is when you run this function,
Yeah.
you get 7.
Yeah.
And so we're like, cool, that's correct.
Yeah.
Now just when you just try and write, there's a new file. There's a write a test that does this.
Okay. Right. Okay. Thank
That's
you.
all, yeah.
That's what I needed. All right. Okay.
So fair point. Copying and pasting from the previous one is not cheating. You can just copy the test from the other example and then just modify it to work. That is totally fine. Writing code from scratch is a waste of time. It's great to just copy code that exists and make it work for you. Yeah.
I have an unexpected problem, which is that I have problems with pathlib 2, even though I think pip says it's installed and everything, but
Do you have content installed on your computer?
no, unfortunately I'm not. control is swapped with.
Yeah, yeah, you don't find it. Okay. Let me see.
I think reverts. I mean, I.
Okay, so just try Python 3. Let's see.
Yeah.
No, that didn't do anything.
Oh well, I mean, I can test it without Pytest. That.
Oh, you need PyTest. Oh, did you
will
install
need
it? Yeah. You need Py. Oh, so you guys will definitely have to install PyTest. It's not a built-in. It's a something you need to install. So you need to. You guys definitely need to pip install PyTest for PyTest to work. And then for this lecture, I go into pandas and requests as well, which also need to be pip or conda installed or whatever it might be. And I have about 2 more minutes. So.
I suspect this. Like when I try to run, it runs perfectly.
Run it from the console. I would run it from the console. It's just running. Oh, I see what's going on. Okay, I'll explain what's going on in a second. All right, I got your last question.
Like,
Yes.
how did you get the fancy verbose stuff to come out? Because the assertion is kind of like this thing. I think should.
Oh, okay, so it's not Python. Actually, that's a good point. I see what's going on. Okay, so I'm getting the same question a bunch of times, which I'm happy because you guys are trying, but we're getting the same problem. So for the purpose of this tutorial, let's go through it, and I'll show you the common mistake that you guys are making, and then I'll show you how to work this. So in my case, I'll run the bill split one first. Actually, I'll just run the run the bill split. I'm trying to think. What do I want to do? Yeah, I'll do this one. Okay, so the bill split, when you guys type in Python, test bill split, you get nothing, right? Nothing's tested. This is probably the first mistake where I got frustrated with Pytest. If you try running this Python program under Python, it doesn't do anything because Python doesn't see anything to do. You define a function and nothing happened, right? The trick is you have to run it through Pytest. So you don't type in Python because then Python runs the file and Python sees that there's nothing to do. You have to run it through Pytest, which is actually the program that reads it in and does a bunch of stuff. That's a really good question. It's the first hurdle I have with Pytest, and it confused me forever. Actually, it confused me like a good 3 or 4 hours before I finally stumbled upon it.
So if normally with Python I would control which of the functions run mediated by the
Yes, yeah. That's not how Pytest runs.
So Pytest just runs every function it sees. What if they take arguments?
That's a good point. So tests don't take arguments because they're isolated. So each test is self-contained, and Pytest has its own test discovery. So this is good. This is why I want you guys to try things first, because when you make mistakes and you feel really embarrassed, and it's really painful, and you remember high school and you don't want to live that experience over again. And now you're going to remember how Pytest works. So there was a really good question when you run this. How does Pytest know how to do anything? Where are the arguments? Well, one, if you're quote unquote truly unit testing, each function is completely independent from every other function. So let me show you Arby's. Actually, I'll show you this near the end. But usually tests don't take arguments. Tests test a specific amount of code and then assertion, and then you're out. You don't actually provide anything. In real code, you do have to provide something. There's ways to fake it out. We're going to get into ways to fake out functions later. But you're not testing your whole library in one shot. You're testing tiny sections of code, and you're building up all. It's like testing a car or whatever. You don't test it on the road. You build these fixtures that hold it, and then you test one component. The way Pytest works is Pytest looks for every function or class, if you're familiar with the XUnit style of testing, that has tests in either the front or the back. And if it has tests in the front or the back, Pytest recognizes it as a test and runs it. So even though I don't directly call this function, the way Pytest is written, it does what's called test discovery and gets the test. I think so I tried putting helpful readmes in everywhere I could. So let me go through this one. The documentation for how this works is right here. Shoot, it's not. Okay, I will add that as a readme. But really not? Oh, that's sad. It didn't. Okay. Yeah, so your first test, run it with Pytest, and I will add in the link to Pytest auto discovery. But if you type in Pytest test discovery right here, the first link will be how the documentation on the full documentation on how Pytest works. You'll see that this documentation is really long. This is why I made the tutorial. Otherwise, you guys will spend like a week trying to go through the documentation and pick out the relevant parts. I just want to I'm going to get you to the point that works, and then you're going to have this whole world of documentation to help you out. Yes, ma'am.
When you first start building out tests, you kind of have to like think of all these different scenarios of like what could possibly go wrong with code, and that's kind of challenging. So
Mm-hmm.
are there like guidelines when you're first starting out of like, okay, say you're supposed to have like string inputs to a function, like these are the things that you should build out as your tests, or just kind of like.
So the question, just so it's on the mic, is that when there's 100 things that could go wrong with your code, how do you know which ones do you test? Is that fair? The answer is, and this is where people get into a lot of arguments online. The answer I'm going to give you is what's reasonable, like a reasonable amount of tests for your code. And I'll preface this in two ways. There's some people that think you have to test everything. So there's this thing called 100% test coverage. I don't know if anyone's ever heard this concept, but there's some companies have this thing where every line of your code, every line of your code has to be tested. So, and it's got to be at 100%. So I'll go back to RVs. When we're testing code, we're running a test over a portion of our code. So I'm going to go through PyCharm because it'll be a little easier to show. So when we're testing this adder function, for instance, in this case, we're testing 100% of our code. But I could have another function in here that's like test def subtract. And then I say num1, and then num2. And then I don't test it. I'll just say something. I don't test it. I just test one function. And your question was, I'm testing this some way, but I'm not testing that another way. You should write enough tests to what you think is reasonable. In this case, I provide number inputs so it works. If I provided string inputs, it wouldn't work. So then I ask myself two questions. If this is an internally facing function to people that are familiar with Python and in the middle of the library, I'm assuming they're more familiar with how Python works, and I can assume they'll use it correctly, and I'll write just a test of functionality, so maybe one test. But if I'm writing tests for something at the user interface level, there's a lot of users online. They don't know how my library works. They can be at varying different skill levels. So then I'll write a lot of tests to test everything they could possibly throw at it. So like things that are public, like it's your car, right? When you go to your car's an interface, right? You got a nice steering wheel and everything like that, and everything's good. As soon as you dive one level in, you take your dash up or you bring your hood, it's suddenly a lot more confusing, because the designers of your car, where it's meant for everybody, it's nice. You've got cup holders, you got steering wheel, you got your stereo, it's all good. As soon as you get one level of abstraction lower into your engine, it's a lot more confusing, and at that point they're assuming that you're a mechanic or a car expert. And so I write a lot of tests for at the user interface level where I expect a lot of people to work, and I write less tests as I go down into the code where I expect people that are more familiar with the code to be at. Does that sufficiently answer your question? I feel like it's good? Okay. Yes?
Kind of a follow-up, might be a dumb question, but why not just put the assertion inside? Like if you don't accept strings in your adder function, why not just put an assertion in there that says like, if type is not integer, then throw an error, right?
Yeah, that's fair.
Conducting a test.
But what do I do with my bill split example? Where do I put the assertion there?
I don't know.
You can't, because it's the Python code itself that's running it poorly. So I can't write an assert for the value that I want to get. So that's the reason for testing. That's another reason for testing. That's a good question. The other reason you don't want to put assertions maybe in your code is it clutters up your code. So testing, if you put out a billion assertions in your code to test for everything in your code, you'll have like 20 asserts to make sure it's a string, it's an integer, it's above 1, if it's square root, all this, and then you have like one line to actually do the addition. If you write your test, you can leave your function as to be simple, and all the extra testing stuff's on the outside. So it's easier to maintain over time as well. I think that's another good reason. Okay, so in the interest of time, I will barrel on. So let's do this basic adding. Let me show you the answer for the adding example. So I'm going to just copy. Test. Okay, so I've added my test function right next to this. So I'll actually show it to you in PyCharm because it's going to be a little easier to see. Here's my adder. Here's my test add. and I'm actually running 2 cases. I'm adding. Yeah, I'm sorry about this. I'm adding 2 and 3, and I should get 5, and then I'm adding 2 and -3, and I'll get -1. To your point, I'm not testing a string input. If somebody used this library and they put a string input in and it failed, that'd be on me because I didn't adequately write enough tests. So the way you run this, and I'll do it the wrong way first. If you run Python testadd.py, nothing's going to happen because Python will look at this. There's nothing to run. It's just function declarations. Just exits out. I want to run it as a Pytest file, so I do testadd, and I'll get, oh, I messed up my code as I was talking. So this is a good example. One of my tests passed, and then I screwed up my code while I was talking to you guys, and now it doesn't work. So my second test failed. So I'm going to fix it, and then we're going to run it again. I think that saved it. I run it now. 2 dots. Cool. If you want the extra verbosity, you put -v, and you get 2 tests.
So is testing mainly for different versions of stuff, or like what are the cases of testing?
Testing, the cases I would think about is it's does the code work at all? Did I actually implement my adding correctly? Because you could implement your adding incorrectly. Like what if I have my adder function and I accidentally add 1 because I don't know, I'm tired and it's late and I want to go home and sleep. Suddenly my code's not working. It's not adding things together correctly. So that's one reason to test. Another reason to test is it's for Python versions. It's the biggest thing is to make sure your code works. The second one I'd say is cross compatibility. The third one is it helps people understand what your library is doing. So when somebody sees this, they can at least see some examples of how your code is working. So for developers, it makes it easier to see what's the expected input, the expected output. Actually, in the last one, I forgot. This is the biggest reason to test. So I need to jump this all the way back in the front. For refactoring your code. So your code will work at one point in time, but then you'll keep editing it, and you'll accidentally reintroduce a bug. Testing makes sure it's what's called there's no regressions in your code. So regression testing, which is a subset of overall testing, is to make sure your code keeps doing the right thing, even though you keep adding more and more features to it. That's actually, sorry, that should have led with that. That's the primary reason for testing. So it's how Pandas keeps working, even though there's a crap ton of developers, because you have tests to make sure that the code still functions the way you want it to function. And the opposite is for people that are usually new with Python. They do Python, they do a bunch of print statements, and then they watch it all, and then they delete the print statements. Well, if you go in and modify your code, you don't know if it still works because you're not looking at all the print statements again. Make sense? All right. So let's ramp up another level. So I'm going to show you. Does everyone, actually, before I move on, does anyone feel confused about testing? At least how to run a PyTest? OK. Because we're going to go up one more level of difficulty. It's going to ratchet up. I'll use, is this readable? No? At least a directory structure? OK. So in most production projects, let's use pandas, for example. I'll use iries first, and then I'll use pandas. You don't actually put your tests right next to your code. So in this example, our tests were right next to our code. So in this one, here's my test. Here's my code. This is not how most projects look. What they do is they usually put the test in a different directory for keeping your projects clean. So I'm going to show you this in pandas and iries to show you the real thing. In pandas, I have my top level repository. You can see here's all the code that goes into pandas. The actual module is right here. And right here, I have all my tests away from all the other libraries. So there's a directory called tests. And in here, you have tests for arrays, computation, everything else. Pandas has a whole bunch of tests. In RVs, the same thing. Our code, our top-level repository is where this package is. So this is the RVs package. In here, there's a directory called tests. In here, we have all of our tests that test out our functionality. So tests are usually separated from code and normally on all production projects. If you look at X-Ray or any NumPy, same deal. Why I'm explaining this to you is because in the next example, this is what we're doing. I'm splitting out the tests from the actual code to declare that they actually are tests. So if I go to the fixtures example, I go to my library. My tests are in here. They're in a different folder than my module. So my module is the actual module. It's the pandas or the RVs or the NumPy or the matplotlib of the world. And then my tests are in a directory called tests. This is very, very typical of testing libraries. So we'll bring this over. Oh, why this thing is always going to fail me. All right, we're going to use PyCharm to show this thing to you. So again, there's a README. Actually, I should bring it up on GitHub, but yeah, I'll bring it up on GitHub. Okay, sorry, I know I'm all over the place. We'll get there. Fixtures example. Okay, this README, the concepts introduced, we're going to test module and directory structure. That's one. I'm going to show you fixtures, and then we already did PyTest flags. In here, again, there's the entire documentation that covers even more of what I'm going to cover. So let's run this test. Same deal. So in this case, my library is the directory right here. In here, there's my module is this piece of code right here. All I'm doing is loading data. So here's where the data science component comes in. Sometimes when you load data in for things, it takes a really long time. So large data sets can take like minutes or hours to load. And you don't want to, it's annoying to keep doing it over and over again. So this is my data loading function. It sleeps for 3 seconds because I have a ton of data, and then it returns 5. I want to test this thing to make sure that it works. So what I can do, whoops, vim tests, and I'll slow, and I'll explain why it's going to be slow in a second. I'm going to test my function, right? So I'm going to import Pytest, and I'll explain why in a second, but we'll leave that there. The next thing I'm going to do is I'm going to import my code. So this is a Python relative import. So from 2 directories up, I'm going to import the my module code. Python has absolute imports and relative imports. Usually tests that are contained inside of a test directory are relative because you're importing the code that's 2 directories up. You can ignore me if this doesn't make any sense, but I'll explain it for people that want to get a little more advanced instructions. In Python's import machinery, if I did import pandas or import RVs here, it would not import the one, it would import the first one it finds in the sys package import discovery, which might be in a different environment than the one that you're in. So you might be testing a different version of pandas than the one that you're trying to test. The reason why this is important, I have 3 versions of RVs on my computer at any point in time. I have the production version, and then I have 2 different dev versions, and I want to make sure I'm testing the correct version. So if I do absolute imports, if I say import RVs, I don't know which one of the 3 it's importing. I mean, I do because I know how Python works, but you could easily screw it up. So sometimes I don't, and then I think my code's doing great, then I upload it, and then my fellow contributors are like, what the hell? You screwed up the code base. So I do relative import to make sure I'm getting the right thing. There's 3 tests in here. So the question before, they're prefixed by test. So I've test not 3, test object is an integer, and test is 5. So I felt like in this case we should test 3 things because, I don't know, just felt like 3 things were the thing to do. I want to test that it's not 3, so shouldn't be 3 because it's 5. I want to test that it's an integer type. So in data science, you're loading in lots and lots of information. If you guys have used like scikit-learn or whatever, you throw an integer, or you throw a string in an integer column, and the regression just throws up, and you've wasted like an hour. That happens all the time. So let's test data types. And then I actually want to make sure it's 5. So I'm going to run this. So directory, oops, ls. So in this case, I'm going to run Pytest, my library, and then test. So when you do your example in like the 5 minutes, this is the function you're going to run, because you're going to run the tests that are located in the my library function. I'm going to run this, and we're going to let this go. And let's go. Oh shoot, I know what I did wrong. Whoops. Shoot at my own example. So I'm going to run, I just want to run one of them, and this is a little contrived, but I'll explain why in a second. So I'm just going to run the test slow function. Or sorry, the test slow module. I'm going to run it, and it takes, in this case, it took 9.04 seconds. So it's super slow. So I'll have someone do math for me. Does anyone want to volunteer? There's free candy if you volunteer. Why do you think this took 9 seconds?
There's 3 test cases?
Yes.
And then 3 seconds each, then you said time to sleep is 3 seconds?
Yes. I have 3 test cases, and because I'm reloading the data every time, I'll just bring it up over here. Because I'm reloading the data every time, it takes 3 seconds to run each time. So in this case, time sleep is 3. I ran 3 tests. You have 9 seconds, and then you have 0.04 seconds for the overhead of Pytest, right? That's annoying. When you run a lot of tests, it's a pain to keep doing the same thing over and over again. I'm literally just wasting time. So if I was testing data loads, if I load the data in every single time I want to run every single test, the test will take hours, and then nobody runs a test, and then there's no point to testing in the first place. So this is the motivation behind fixtures. Let me show you what a fixture looks like. So in tests, here's test slow. There's no fixtures in here. Here's another version of Pytest. And this one's going to be a little confusing, so let's talk through it, and then I'll show you the difference. Or does someone want to see the Does someone want to see the results first, and then I'll show you the difference? All right, results first. This test took 9 seconds. I'm going to run Pytest. Oops. And then I'm going to do test save time with fixture. And I know we're getting a little save. Okay, test save time with fixture. I run this, and it's going to run in probably 3.04 seconds, 3.03 seconds. Here's test with fixture. Here's test slow. So test slow has 3 functions, 1, 2, 3. Test save time with fixture also has 3, 1, 2, 3. They're the exact same test. I test that 5 isn't 3, that result fixture is not an integer, and this equals 5. The way I'm saving time is I'm only loading the data once through a fixture. So fixture syntax in Pytest is a little confusing. So what you do is you write a function, and you don't have to call it a fixture, but you call it something. You have it do the really expensive slow operation. So this is the really slow thing. And then you have it return the result. And then with all the other functions, you give it an argument that's called result fixture. And what this does is it passes this result over here and then does your test. You have to import Pytest here. So this is where you have to import Pytest to get access to a Pytest decorator. So there's a lot of if I go through all the advanced, I'm going to say all the advanced Python words that you can immediately ignore, but you're going to have relative imports are good. This is called the decorator. This is the fixture function. And then I'm passing fixture as an argument to these other fixtures, and then it does stuff. In plain speak, just add this thing to the top of your code that says pytest.fixture. It means this will run, in this case, once, and I'll explain in a second why. And then it'll save this result and give it to these 3 functions. So it loads the data once for 3 seconds and then runs 3 tests.
Do you ever use other scopes in session?
Yes, you could. And I'll explain the scoping in a second. So for now, I'm just going to leave it to you guys to just know, take this as magic when I say scope equals session, and then I'll explain after you're done with the activity what the scoping means. I know I've been talking for like 15 minutes, and this is where people start zoning out. So with that, what I want you guys to do is I want you to try the next example. And here's what's going to happen in the next example. I want you to test this function or this object. So you can ignore all this code, but there's one trick here. If you try and make this object twice, the second load is going to take a minute. So the trick here is you need to write a fixture so you can write 2 tests for this object, but only run it 1 time. That's the point of fixtures. Any questions on why this is contrived, but I wrote it in a way that forces you to do it this way. Otherwise, I know what would happen. You just write it twice, and you'd miss the point. Does anyone have a question on why I wrote it this way or what it's replicating?
We will get 1 minute instead of 2 minutes.
You will get really fast. You'll get 1 second. If you try running this object twice, though, you're going to end up getting 1 minute because the second time it loads, it's going to take a minute to load. So if it already was created, it's going to sleep for a minute before it finishes. This time, if you want to see what it does, you can run it. So I'll give you an example. I'll run the code to give you an example of what's going to happen. So cd07. So if I run Python my library, so I'm going to actually run this. I'm not going to run a Pytest. Python my library, my module. It used the object only once. This was nearly instantaneous. If I try doing this again, though, and I say print finished again, I'm going to make this a little bit less because I don't want you to stare at me for a minute. But I'll make this 5 seconds. The first one will be instant, and the second one is going to take 5 seconds before it loads. So this is where you don't want to do a thing twice. What I want you guys to do is use a Pytest fixture to test this, and the test should take less than a minute. And I want you to test that adding still works. That I can give this thing a number, and then I can give it a number in another number, and then it does the adding. So let's see. I'll give you 10 minutes to give that a try. So we'll end at 2:30 or 2:31. Yeah. Again, copying and pasting code from the previous example, not cheating, totally valid. Yeah.
The method name?
The fixture is the method name.
Yeah. Okay, so result fixture could be like anything.
Oh, you can name anything. Yeah,
Okay.
your fixture can be named anything. It doesn't have to be called results fixture. It can be called whatever you want it to be. And I'll bring up the, just so you, since you guys have laptops, this is the example. So you can use this as a guide. Admittedly, by the way, it helps to have two screens when you're testing because you have one screen is your code, the other screen is your testing, so you can look back and forth. It's a little hard doing it side by side, doing it on one small laptop screen. Oh yeah, you definitely asked the question. That was a good question. I'm sorry I answered it in a kind of vague way, but did it make sense?
Yeah, because I've been working on like internal Python package that
Yeah.
we're developing.
Yep.
And trying to write like unit tests for it.
Yeah.
And I get kind of overwhelmed. Like, okay, like how much do I need to test? Like,
Yeah.
But it's more like what you said. Like the main goal is that we have other people contributing to the project. So like making sure that they're not using 2.7 or like changing.
That still works on the computer. For your code, is it people that are outside of the company that are working on it, or inside?
The company, but they're on like different teams. Use Windows.
Yes, that's a good one.
Yeah.
Okay. So yes, that's a really good use. I forgot operating system.
Yeah.
But yeah, same thing. So as much as you think is reasonable, because if you had infinite time, then you test everything. But like you can write like 50. You could write 50 tests to test like a square root function or like the add function. You could test everything, right?
Yeah. Right.
Eventually, you could test really big integers because it'll cause memory overflows and be like, I tested for memory overflows. But like, are you like, who's gonna do that? You know what I mean?
Yeah.
Like, you're gonna sit at work for like a zillion hours and write 1,000 tests.
Yeah.
Yeah. But I will say the other way I do it, if I'm being lazy, is I write like a minimal amount of tests, and then when somebody messes something up and like it causes a problem, then I write a test to like cover that one.
Yeah.
And then I just keep writing band-aid tests, and then over time, I'm like, okay, I've got all the things that like normally get caught.
Yeah, you probably have a better idea too. Like the more you do it, like what general
What
things you
probably
need
will
to test
happen.
for.
Yeah. I don't know. It's like seatbelts in cars after. The first cars are really crappy, and you just ran into things. And then over time, they learn like, oh, we should put an airbag here, and we should put an airbag there, and
Right.
we'll have an airbag up here. And now we're like safe, but it took a lot of car crashes for that to happen.
Yeah.
It's like sort of a similar thing with code. He's got it. Make me proud. Yeah.
The example we're using is from the picture examples.
Mm-hmm.
Under tests.
Yes, the first one. Yep.
And then the 07 one
Mm-hmm.
is the one that we want to write the pictures.
Yeah. Yes.
For we want to write the picture for the adder.
For the adder class.
So they fail, but at least they're failing promptly.
Yes.
So, I'm making one of your objects.
Okay.
So I'm making one of your objects
Mm-hmm.
for the result fixture,
Mm-hmm.
and then s dot add more. Does that change its number internally? I guess I could cut that. No, it doesn't.
you know, it just returns the number.
Okay, sorry.
But it's very close. You're really close. You're like one line off. But you got the gist of it.
Yeah, yeah.
So you're good.
Oh, I know what's going on here. It's basically at the beginning. I like carry on kind of
Oh yeah, you have to activate the right one.
It's in my stack jar.
Mm-hmm.
Pytest is mainly used for to have a common data which is being used for attendees. Is that the main?
So there's fixtures have a good question I got is what are fixtures used for? Fixtures are used for the biggest reason to use fixtures is to save computation. So if you're running I'll give you an example from RVs. It's a Bayesian computation library. Running a Bayesian model could take like 5 minutes or more. But we want to test the model. I don't want to run one model every single time we got to run a test. So I run the model once, and then we just reuse that model over and over and over again. And Pytest ensures that it's just there and available. There's more advanced usage for fixtures. I won't go into them in this basic talk, but the link will tell you more about them. So I think we'll be good there. All right, I'm gonna show you I'll run the example and I'll show you how it works. Solve test. All right, so Vim test adder solved. So in this case, I instantiate the fixture one time, and then I run this twice. So here's the fixture. It instantiates the object, and then I reuse the object here by saying adder fixture. This doesn't even have to be fixture, by the way. This could be adder anything. I'm gonna break my code by doing this. For instance, but you don't have to name it fixture in this case. And then I have my code. So when I run this, Python. I put it in the wrong place. So cd my library. Cd test. Yeah. So rm test adder. cp dot slash solved. Oh man. Okay. Just gonna use a GUI. Okay. Pytest, my library, test. This should run. Oh no, I messed up. All right, let's try this again. There you go. It runs twice. If I do a -v, you'll see both tests come up. This one runs really fast in 2 seconds. So what I'm going to do is, so the code looks like this right now. I'm using a fixture. So here's me using a fixture. It takes 0.02 seconds to run. If I took the fixture out and I instantiated this twice, like this. So what I didn't want you to do, this is why I'm trying to show you. You could write the test like this, and then say adder, and then they say adder here, and I get rid of it. So now here's my code. Does anyone want to take a guess how long this would take to run? Yeah, it'd take over a minute, because it's going to instantiate once, and it'll be fast, but this one's going to wait a minute before it tests. You can run this, and you can see that the first one's going to run, and then we're going to be standing here for a minute while this thing still goes. That's the point of fixtures. This is a little bit more of a contrived example. This one ran in 5 seconds because I modified my module here to be 5. But in a real life example, as you guys work with data, loading data takes a long time for really big data sets. Do not do it more than once. Besides wasting time on your end, it actually puts a huge load on the database. So my coworker did this. He was running tests, but he was just hitting the database every time, and then the DBAs got really angry with him because he was hitting he was just slamming the database with queries every second to get a crap ton of data out to do his test, and he's like, oh, everything's fine, it's running my computer, but the server was on fire. So you know, you don't do it. Besides wasting your own time, you're gonna piss off somebody that has to run like the Spark cluster or whatever that you're running on. So don't do, just use a fixture, load it once, and then you're being like sort of responsible with usage. That's my sage advice to you. That's where the data portion comes in. We're gonna go through. I'm gonna skip to the end and skip back a little bit. We're gonna definitely run out of time before I get to how Monkey Patch works. But I will be at this conference all 3 days. So if you guys want to go through it, you can just come find me, and I will be happy to walk through any of this code with you anytime. So we can go through it there. You have my contact information too. You can send me a message, and I'll try and help you out. So yeah, if you feel confused, don't leave this conference feeling that way. Come find me. We'll talk through it. Like I'm not like gonna be a really mean person after this lecture ends. We can still chat. So let's do mock. I'm gonna explain how mock works. So let's go back to mock example. Since I have GitHub up, let's just use that example. Oops. Computer doesn't want to cooperate. All right, well, that's why we load things locally. OK, so mock lets you create fake stuff in Python, fake objects. The reason being is everything in Python is an object. You guys might have heard that. Means that like with data frames, there's all these little dot methods that let you do cool things like rolling sums or whatever they might be. But it's really complicated sometimes to create these objects. Like creating a data frame sometimes isn't easy. You got to load it with a whole bunch of stuff. But you want to just test one piece of this entire thing out. What mock lets you do is basically fake out the majority of the object and just add in the little things that you need. And let's go through. I'll show you an example. And I'll give you 3 real-world examples to motivate this. When you fit a model, if you have to fit a model and then you want to call dot predict in scikit-learn, dot predict takes 2 functions. It takes probably an x and a y, and it gives you an output. If you have to fit an entire model just to test that your dot predict works, you're going to be waiting. Like you're wasting all that time fitting that model. You just want to make sure this like one tiny thing works. Why do you have to do all these steps beforehand? That's an example where you use mock. You don't want to test that the whole model fits. You just want to test that your dot predict does something. It doesn't totally fail out. And maybe in this case, your dot predict fails when you input a string. You don't have to fit a whole model to check that your dot predict doesn't take a string. Another example is calling an API. You don't always have $1 bazillion to pay Google to call the API 1,000 times. So I have 2 students here that were in my boot camp. Part of my class, they were hitting an API, and then all of them hit a rate limit within like the first 30 minutes, and they couldn't use the API anymore. So testing against a real API is expensive. Usually someone's going to charge you money for it. So what you can do is you can mock the API response, which is what the next example is. So you can test against something that's not the real API. So when you get to the real API, you're pretty sure it works. And then my example is calling a database. I call databases a lot of work. If I'm testing against a real database, somebody is going to get really angry at me that I'm opening connections like a zillion times to test a tiny thing out. So let's go through an example of mock. So in my library, I have a module. And in this case, I test that a data frame is over. If the data frame is over a million rows, it looks like it's big. Otherwise, if it's less than a million rows, it'll return false. So I want to make sure that my is data frame big object it works. Now here's a trick. If I want to test this out and I have to make a data frame that's a million like wide, and we can actually just make this even more ridiculous. If I have to do this, this is going to be super expensive. Like I'd have to generate a data frame that's like, in this case, looks like multi-billion shape wide just to make sure this function works. That's really annoying. So what I can do is I can import mock, and we'll go through the import in a second, but I can create this mock thing, and then I can just give it an attribute that's huge, and then I can see what the function is. So this is not a data frame. This is a mock, and then I can add something to a mock. So I'm going to show you outside of the context of the test real quick, just to make it a little more clear. So IPython. So from this one, you get it from Python's inbuilt unit test. So unit test.mock. Import mock. And I can say a equals mock. And a equals mock. So I'm instantiating a mock object here. And if I can say a.name, it's nothing, but I can say a.name equals like test. And now I can do a.name, and wow, that's a test. I can do a.shape equals 2 and 1,000. And now when I do a.shape, I get that back. It's basically just like this amorphous thing that I can just shove attributes on to see what happens. You can make another mock object. I do this all the time. You can do mock return value equals hello. Return value. Now when I do this, it acts like a function that returns something. So now I don't have to run in the entire function. I can just fake out a function by having this mock object. So mock is a specially designed object, and it's in Python's inbuilt unit test that is completely built to be this, like, I don't know, you guys play Pokemon, Ditto? You guys remember Ditto? Ditto can be any Pokemon. This is like the Ditto of Python objects, where it can be any object. So you can just slide it in, and that way you don't have to deal with something expensive. In our particular case, I do not want to make a data frame that's like 20 billion integers long just to test that my big function works, because that's a huge waste of time. What I'm just going to do is I'm just going to say that this shape is big, and then I'm just going to test that this is true, and then this is false. Anyone have a question why I'm doing this?
So it should be data frame, not shape, right?
Oh, yeah, actually, good point. That would have failed. Good catch.
Wait, so
That would have been fun. So,
so is mod essentially taking a small piece of your original, or is it doing something else?
mock is just this thing that you can just make it act like anything else. You can tell it what to do. It's the most nice of Python objects that'll just take any attribute or return any value and just sort of sub in and act any way you want. I guess the way I should say is mock is an object that will act any way you want it to act. And in this case, when I ask it what its shape is, it's going to tell me this number. And this is going to this function, the way that gets a little bit more into the way Python works. But all this function is doing is it's seeing what the shape object is, and then seeing if the row count is bigger than 2 million. I don't need a full data frame to test this function. I just need something that looks like a data frame, because Python is what it's called duck typed. This is a whole. There's statically typed. There's duck type. Python is duck type, which means that Python doesn't check that all the attributes exist before you test, and so it makes it easy to do this sort of testing where I give it an object that looks like a data frame and it's just happy and like life goes on. It's the CS like 300 way of saying that. Does it make sense why I'm not creating a data frame? Yeah. Okay. So I'm going to run this test.
Are you essentially beating your test and saying that I'm going to test this, it's supposed to act like this?
Yes. So that's a good point. You better really know what your thing is supposed to act like, because if you don't and you create the wrong mock, then you're not actually testing what's going to happen. So this requires you to know how your code works. It's I've done that before. I've had mocks, and then I'm like, wow, my code's great. And then somebody uses it, and they're like, your code sucks. And then I'm like, oh, no, but I tested it. And they're like, your tests are wrong. I'm like, shoot. And then it's embarrassing. So yes, you have to actually know how your code is going to work. So I'll run this for you real quick, and then we're going to go through the mock example, and then I'm going to do questions. So Python, my library, tests. This should work. No. Oh, because I made my own mistake. Not Python. Should be Pytest. And then, of course, I run into my own problems. Maybe this is what happens when I do live coding. Did I have it right before? Well, this is going to suck. Oh, I know why. Sad. Okay. This example definitely is broken. So let me see. I'm going to see if I can fix it in a minute. Otherwise, I'm just going to say we're going to do the example.
You changed your code to be like 1 billion, trillion with a bunch of zeros. Is that still right?
Yeah, I think actually what it is because I call a magic. So this is a good example. I screwed up on my mock, and now the tests fail, and now I look like an idiot in my own Pytest tutorial. So this is a really good example of the dangers of testing. I know what the error is. It's going to take me more than a minute to solve. For now, I'll let you guys accept that mock does the thing that it does. I'll let you try doing the example, and I'll show you the solution, which I do believe works. So I'll give you like 4 or 5 minutes to just try out the mock object. So see if you want to try out number 9, and then we'll run the solution, and we'll talk through it then. I apologize. On your computer works?
If you just changed it, it's probably your zeros.
Oh, yeah, maybe. Here, I'll just try it out real quick. Git checkout dot. Yeah, this is, sometimes it's nice to have slides because then you really can't mess up slides. But this is a good example for testing, right? I actually screwed up my code in the middle of my talk, and then my test told me that I screwed up my code. So maybe this is, it's like, I don't know, it's like those videos you see on YouTube of people on bikes crashing into things, and you're like, I should wear a helmet. It's like that sort of, I don't know. Oh yeah, okay. So yeah, I did screw up my code when I modified it. So there was an accidental explanation of testing. I thought I was doing something that I thought would work, and then it clearly didn't work, and then Pytest told me that it didn't work. So the example on GitHub works. The one that you see in the video is the one that doesn't work, as we saw with the Pytest. So there's a good example. Testing for the win. I'll give you till 2:50, and then I'm going to cut it off, and I'll take questions. Mm-hmm. 15 minutes, okay. Mm-hmm. So return a value from mock is so from unit tests mock import mock, and you do mock return value equals 42. Oh, I have to put this into a function.
But what if like it's so like you're mocking a series and then the series has a sum function in it. So how do you do that for like a particular method within that object?
Yeah, so you can say series equals mock, and then you can say series dot sum equals mock. Return value equals 40. So you're using two. So in this case, there's two objects. There's the series object, and then there's the sum object that does something. So you can, this can be multiple layers deep. All right, so in the interest of time, I'm going to talk through a solution that hopefully works. Pretty sure it does, but that's going to find out. So you can do this two ways. I showed one way, and let's see if I can lag code the other way without making a mistake. So let me try it real quick. CD. 09. Pytest. My library tests. Yep. So there's two ways you can do this. I get a good question. You can say a series is a mock object, so I'm mocking it out, and then series.sum, that return value is 2000. Mock does this thing where if you call a dot and you don't tell what it is, it just creates another mock object, and then it gives you the return value. The other way you can do this is you can say series.sum equals mock, and then the return value, in this case, I'm going to call this return value equal to 1. So these two end up doing the equivalent thing. This case, I guess I didn't explain it well, but I know the way mock works, and if you just call dot and then this, it returns another mock object, and then I can set the return value manually myself this way, or I can create a mock object. I can assign this object to be another mock object that returns the return value. I know this is getting like Inception-like, but I mean this is pretty reasonable in tests. This happens all the time.
You can't do mock.sum because the example you did mock.shape.
Did I do mock.shape? Oh, you can do that. You can do whatever. Mocks will take on whatever attribute you give them.
But I'm saying if you name series equal mock and then you do mock.sum.
Oh, yeah. So I will give another disclaimer. This is maybe I screwed up. This example, I believe I did make an error on. So what I'm going to do is don't use this as the actual example. I will, right after this talk, I will fix this, and I will push this to GitHub so it is 100% correct. It works, but there's a reason why it works, but it shouldn't work that way. But so for now, example 8 that you've seen on these slides, please just ignore it. There's an error on it. I will push right after this tutorial a completely correct version. This solved version actually is correct, 100%.
Explain like in a sentence why it's not as it should be.
The other one was assigning an attribute to a module level namespace, which actually isn't a mock object. It's the mock module. So that's where I made the mistake. So this is a really good example of me writing a tutorial and then screwing it up and it works, but there's still a bug in my code. This is, I don't know, I can't explain it. I didn't do that on purpose. That's actually just what happened. So this is why you should test. Because we make mistakes and testing helps you catch mistakes most of the time. Usually all the time, but and this is also why we still do code reviews, by the way. So there's testing and there's code reviews. It's for both aspects. Mm-hmm. Yeah, you can assign an object to the return value. So Python's a crazy language in that like everything is an object, and objects can return other objects, and functions are objects, and like the whole world is objects, which is not true of every language. If you work with other languages like C or even R, not everything is an object in R. Like R has integers, and they're just integers. But in Python, integers are objects. I know this is far off computer science, but if you start writing a lot of Python code, these things like start mattering because that's how the language itself functions. All right. With that, I'm just going to leave it open to just any general questions that you guys have at all for 9 minutes. I don't want to take up the whole time talking.
So do you at all write tests that depend on tests? And if so, would that be a way to not do that?
You usually shouldn't write tests that depend on tests because then if one test fails, you don't know which one is the failure, the upstream test or the downstream test. So while you could, it's usually frowned upon because it's just like, then it becomes really hard to tell what's going on. So one of the values of doing unit tests, if you write in small, is that only one test will fail, and then you know where the error is in your code. If you write tests that depend on tests that depend on tests, suddenly your test is running through like 10,000 lines of code, and all of them will blow out, and you can't tell what's on fire. Does that make sense? So,
I guess.
Yeah.
I mean, sometimes you want to test one. I guess you covered it already, but sometimes you test something that you want to test first before you test something else.
Ideally,
and then you shouldn't do that. I know. But sometimes I feel like.
Yeah, it's fair. So this is just how you decide to code. There's some purists that say unit tests should be unitized. They're as tiny as possible, and they test one function, and they're completely on like write a bazillion unit tests and mock everything. but that means you write a lot of test code and write a lot of mocks. And the nice thing is then you get really isolated tests that test one tiny specific thing. Some people are like, why don't I just test my whole function at once? So why don't I just call my model fit and just test the entire model, and then see if I get the correct prediction. And then in that case, yeah, it's easier because you wrote one test and you're testing all your code in one shot. But if you get an error, it's hard to tell where it goes. I'm like somewhere in the middle. In RVs, we're like right in between. We test our entire plot function at like 100 lines of code, and we think that's close enough. So it just depends on where you're at.
How do you organize your project when you're developing for testing so that like your users don't have to like your Pytest or whatever is included in the requirements and you just keep that completely separate?
Yeah, that's a really good example. So how do you split up test requirements and dev requirements? Let's just go look at RVs because it has it. So I'm just going to keep using RVs because I know it super well. We have regular requirements, so requirements of txt. So if you want to use RVs, this is your dependencies. And if you want to develop on RVs, then you also install the development, which is all these other things. So we split them up, yeah. In RVs, we split up our dev requirements from our regular requirements. So to go one level deeper, there's people that just use a library. They don't need Pytest because you're just running the library. But then there's people that are developing in RVs, and then you do need Pytest because we make that a requirement of development. So I don't want everyone who uses RVs to install Pytest. It's kind of a waste of time. But I do want everyone that develops with RVs to use Pytest. Or I should say we, the contributors. If you look at pandas and things, they should be very similar.
I have a question. It might be hard to answer like a general way, but is there anything particular about Python besides things like mock that are different from testing in other languages that we should look out for?
This is a hard question because I'm just, like so much less familiar with testing in other libraries because I don't strongly develop in other libraries. I'd say the biggest. Oh, I know. Actually, here's a big one. So Python requires more tests, in my opinion, than actually for a fact than like C# and whatnot. Because in C#, because they're statically compiled, you get interface checks by the compilation themselves. If the code isn't compiled, that itself is a test that the code works. With Python and even JavaScript, because they're duck typed, you don't know what an object is until you run it. So you end up with more. I end up with more tests that test that interface exists and that the object types are the types that I want. Versus in C#, I don't test for that because it's like or Scala can only be that one thing because it's in the definition of the code. Does that make sense? So just test to make sure my code runs or my code does the thing I want it to do in all languages. But in Python, I definitely have to check interfaces and types. So in data science, a lot I have to make sure like integers are integers, they're not floats, that strings are actually strings. And then there's Python 2 and Python 3, so I have to double check that in Python 2 it's the correct string type because there's just differences between the two languages, all that sort of stuff. Well, Python 2 and Python 3 are two different languages, so I have to make sure that the string type is different. Python 3 is Unicode, Python 2 is, I'm blanking at the top of my head, but the string handling is not the same.
So I'm going on that note about the strict typing of stuff. I think it's Python 3.6 or 3.7. You can actually start implementing types in your functions if you want.
Yes.
What are your thoughts on doing that versus keeping your tests?
It's really cool if your users use Python 3.6, which a lot of them don't, so then we can't. So we write a lot of tests in RVs because we support 3.5. And PyMC still supports 2.7, which doesn't have type hinting at all. So then you can't. But to your point, like if everyone was on 3.6 or higher, then instead of having to write as many tests to test the type of objects, you could just have the linter, like MyPy, try and verify that it's that type. But it's important to know that they're called type hints because they're not guaranteed. They're just hints. So it's still not just because they have hints doesn't make it a strongly typed language. It's a good question.
At the core of all your tests was an assert statement.
Yeah.
Are there any other sort of test statements that we can do besides, or is it always an assertion of a Boolean?
No, that's a good question. So there's the question was, do you always have to do tests that are that is this thing a Boolean or not? No, there's other types of tests. I'm going to see if I can find one really quick.
Yeah, like you said, you were like testing the whole plot thing.
Yeah, verify. Let's see if otherwise. Okay, in this one, we're not testing. In this particular function, we're testing that a value error is raised. So the question was, in my functions, I'm just checking that, like in our adder function, we're checking that 2 equals 2. Then we also had a question, should I check string types? Well, in an adder function, I would want to check that an exception is raised if you pass in a string. You can write a test that is, if you input a string, do I get a value type error or key error or whatever the case might be. So you can test for exceptions too. It's not just conditional testing things. I can also test logs. I can test logs. I can test that files are written. So you can write tests and make sure that your program is writing things on the file disk, so file system. So with data science a lot, I dump Excel files. I don't want to actually write 1,000 Excel files. I just want to make sure that it would write 1,000 Excel files. So I can write a test that checks that 1,000 Excel files would have been written, which is not necessarily like a Boolean, but a check that like another thing would have happened. Also a good question.
So when you contribute to open source projects, you generally require to do testing.
Yes. Most open source projects will say will want you to write tests. Nearly all of them will. This is the only way open source works, because if people just checked in code, like every library would be broken all the time, just for a fact. Like you guys have written code yourself. Like you start writing and there's going to be bugs, and if you check that in, then everyone's installation of pandas will be broken and the world will be on fire. So every library usually wants you to write tests because they want to make sure that you're validating the functionality you wrote and your library still runs and isn't going to break everyone's pip install pandas. So yes, that's another really good reason to test. I'm going to go on a limb and say all major and stable open source libraries are going to require testing. And most companies require testing internally too. Most companies don't like the critical packages breaking like right before the end of the financial quarter. So I can imagine that a couple of people here have companies that are asking them to write tests. These are all really, you guys have more questions? These are all really good. I'm completely out of time.
Thank you.